Let's explore how we get particular colors on a web page. And typically we're going to use color for color of text, background color, maybe the color of a border of maybe an image or a table or some tag on a web page. So what is involved with color? And the challenge really is to represent all the colors that the human eye can distinguish. And represent them on basically on a monitor on a web page. So that is a bit of a challenge to us because the human eye can typically distinguish about 10 million colors. So we need some sort of color representation system that can generate 10 million, at least 10 million unique colors. Okay, and if we can do that, we can achieve what's called true color. Okay, now the problem about that is, do we have 10 million words to distinguish individual colors? We don't in a particular language. Okay, and not only that, but colors can have, words for colors can have different meanings depending on what culture and what language. Like for example, the word glass in Irish means green. Okay, and I think it just refers to green for something that's living, like grass. But glass also means green in Welsh, and it also means blue in Welsh. So we have an issue there. Okay, so we don't want the same word to mean kind of different things to different people. So we're stuck, and it turns out that we only have about 140 words for color that are agreed in by the kind of W3C authorities. Okay, so we that leaves 9,999,860 colors that we need to be able to create. So we have no option really but to go numeric in order to represent all the colors that the human eye can distinguish. Okay, so the question really is, we know computers are binary devices. So how do we use binary numbers to get to 10 million? Okay, so let's go on to the calculator that is on your typical Windows machine, and usually it opens with the standard. But I'm going to go to the programmer version. Okay, and let's type in 10 million. And what we see here is we see that we are generating 10 million. We can see down here BIN for binary, 4, 8, 12, 16, 20. There's 24 bits. Okay, and 24 is a really useful number because to generate colors on a monitor, we use what's called the RGB model, red, green, and blue model. Okay, so we have 3 primary colors. 24 bits will get us to about 10 million. Okay, and the great thing is that 24 is exactly divisible by 3. So that means 8. Okay, 24 over 3 is 8. So we can use 8 bits for red. We can use 8 bits for green. We can use 8 bits for blue. Okay, so let us write in sorry. Okay, if I write 255 decimal, what you can see here is that 255 decimal equals 8 bits maximum, all 1. Okay, if I write in 0, 0 is actually just 0 binary, but that is essentially 8 zeros together. Okay, now it turns out that the way monitors work is that each pixel is made up of 3 components, one for red, one for green, one for blue. And we can basically vary the voltage on each of these components in 256 steps, okay, from 0 to 255. So by having maximum intensity voltage on one of these tiny little elements in a pixel, we can get maximum red, or we can get no red. And similarly for the green part and the blue part. Okay, so by mixing these together, by having 3 separate voltages in each of these components of the pixel, we can get a mixture of red, green and blue. And it turns out that I don't know off the top of my head what 24 ones is, but if we multiply 1 megabyte 1048576 by 16, we get 16,777,216. Okay, now so that is the amount of possible variations of 24 bits. Okay, 16,777,216. So the lowest version is going to be all zeros, and the highest version is going to be 16,777,215. Okay, so let's just write that in. Okay, and we see when we do that, we get 24 ones. Okay, but notice as well what we get. We get 6 hex characters. Okay, so hexadecimal is just shorthand for binary numbers. Okay, so each group of 4 bits, say the first set of 1111 here, that is equivalent to F in hexadecimal. Okay, so if I write something like 15, okay, you can see that's giving me 4 bits, 1111, and it's giving me F in hexadecimal. Okay, so 15 is equivalent to hexadecimal. 9 in decimal is also equal to hexadecimal. Okay, so hexadecimal, you know what a hexagon is, 6 sides. We use 6 letters, A to F, and then decimal, we've got our 10 decimal numbers, 0 to 9. Okay, so hexadecimal numbers are made up of a combination of 0 to 9 and A to F. Okay, and basically what we end up with is 1 character in hexadecimal replacing 4 bits in binary. So hex is completely intimately related to binary, much more so than into decimal. Okay, so it's a shorthand. That's the way I think of it. It's a shorthand for binary. Okay, now what this means is in order to get any of these colors in true color, instead of having to write out 24 bits, we can just write out 6 characters. Okay, or we can write out 3 decimal numbers. Okay, so let me go into Microsoft Paint, which is freely available. So what I'm going to do here is I'm going to click this fill with color here. Okay, and I can go over to edit colors. And what we can do here is we can write up to 255 for each of the 3 primary colors. And this is the color we're going to get. Okay, so when I have 255 of red, and no green and no blue, surprise, surprise, we get complete red. If I put 255 of green as well as 255 red, we get a secondary color, okay, called yellow. Okay, if I get rid of that, if I get 255 of blue, okay, I'm now getting purple, sometimes called magenta, sometimes called cyan. Okay, and then I suppose I could put red at 0 and I get the third secondary color, okay, called turquoise or cyan. Okay, so you can just experiment and you can get basically any of the 10 million colors in here, and in fact we're getting over 16 million are available. Okay, if we had 23 bits, we would only get up to 8 million. Okay, 8 million and a bit. So that's not enough to get true color. So we need 24 bits, and it's brilliant that it is divisible exactly by 3. So we have 8 bits per color, okay? And 8 bits means 256 possibilities. 2 to the power of 8 is 256. Okay, so let's just have a quick jump over to W3 Colors here, or sorry, W3 Schools here. There's the link here. It's on the web page resource I'm giving you. Okay, and we can see here we've got the RGB model, and we got hexadecimal as well. RGB just means kind of using decimal numbers. Okay, so we've got 140 standard color names. There they are there, and notice as well we're also describing them as a hex number. Okay, so those are the words. So we can just say in CSS color colon blue, color colon cadet blue, and so on. Okay, an alternative way to write colors is to write like color colon and then RGB and then 3 numbers in brackets separated like that. Okay, or alternatively we can write a color as hex like that. Okay, so hash FF0000. Okay, now if I just jump over to the resource I'm giving you here, I have got 3 H2s and I've got an ID for each of them. Okay, so I'm just experimenting with colors for the text, the background color for the second one, and the border colors for the third one. Okay, and I'm just mixing the RGB, the hex, and the 140 words approach. Okay, so color words, you can see the first H2, the text is in red, background color yellow for the second one. And then for the third one, what I'm doing is I am setting a border color. Okay, I'm setting a different color for each of the 4 sides. Okay, so we use the box model, blue at the top, RGB 2551280 for the right. Okay, that gives us orange. Okay, so we have maximum red, we have half green. Okay, notice 128 is roughly half of 255. So we've half as much green as red practically, and then we've no blue. So we're getting orange. Okay, and then I just jump to the left hand side, hash 222222. That means very little red. Okay, very little red, and similar very little green and blue. So same amount of red, green and blue, but very little of each. That means we're getting a very dark gray heading towards black. Here it is over here. And then 888, you might think, well, why don't I have 6 numbers there in my hex number? The reason being is that 888 means 888888. Okay, so when all the digits are the same, all the hexadecimal digits are the same, we can just write them in one like that. Okay, so a hexadecimal number has either got 3 of the 3 digits, or it's got 6 digits like that. Okay, so do experiment with this and just get a sense of how these colors can change. If your background color is the same as your color, you're not going to see the text. Okay, so for example, background color like that. If I set that to be red, save that, come over here and refresh, you can't see the words. Okay, they're in there when you highlight them, but we can't see them. Okay, so have fun experimenting. Do read up. There's great resources online about color. One thing you're going to have to think about in terms of your website or as a web developer is, what about kind of limited color schemes? So usually we use very few colors on a web page, but we use them sparingly for extra impact. Okay, more about that later in the semester.